Task B3. This video covers how to inspect, test, repair, or replace ignition primary circuit wiring and components. Ignition system primary wiring faults will most often be seen as bad connections at terminals and connectors. Probing wiring through insulation to make electrical tests will damage the insulation and can lead to wiring corrosion and high resistance, especially in climates where road salt is used in the winter. Test primary wiring for unwanted resistance and current carrying capacity by performing available voltage current ramping tests and voltage drop tests or measuring resistance with an ohm meter. When replacing primary wiring, use the correct gauge wire. Solder connections and seal the repair with heat shrink tubing to provide adequate weather protection. Test primary components such as the ignition switch or OBD2 modern electronic fuse box, if used with a digital multimeter. Check both power and ground circuits to ensure proper primary circuit current flow and operation. Following we'll see a current ramping test. Let's take a quick analysis of what an actual coil current waveform will look like on the oscilloscope. When analyzing an ignition coil current wave, you have to be mindful of the different test points throughout the wave. On the bottom waveform, you can see a shorted ignition coil. This is denoted by the vertical line at the beginning of the pulse. This is the beginning of the coil charging phase. If you look at the upper waveform, the slanted line signifies that the ignition coil is slowly charging to its maximum magnetic field output to produce the spark. Any healthy ignition coil should have this slanted line without any sudden vertical spots. The slanted line at the bottom signifies that a few of the ignition coil windings are actually shorted. This will inevitably translate into a lower kV spark value, a no start, or a misfire. The sudden current surge is what gives this vertical telltale sign at the beginning of the wave pulse. Further up the bottom waveform, we then see that the line slants again into its normal expanding magnetic field. The actual space between the beginning and end of the horizontal zero line is the ignition coil dwell period. So in summary, whenever analyzing an ignition coil current waveform, always look for a slanted line with no sudden vertical spots. Another point of interest along the waveform is the ability of the ignition module to provide the proper amount of current for the coil's magnetic buildup. This you know by measuring the voltage at the highest point along the wave, or at the top of the crest. Keep in mind that you are reading a current value translated into a voltage wave. The clamp-on-amp probe does exactly that, which is convert an expanding magnetic field produced by the amount of current flowing through the circuit into a voltage signal that the digital oscilloscope can read. Most coils will draw between 4 to 6 amps, depending on the manufacturer. So again, we are looking for that slanted line at the beginning of the charge cycle, and at the same time you are also looking for the ability of the ignition module to provide the right amount of current to trigger the spark. At this point in time we are using the Snap-on Vantage to make our necessary measurements. This is actually a very simple test and consists of clamping the amp probe around either of the two ignition coil wires, connecting it to the graphing multimeter, and properly analyzing the wave. After powering the graphing multimeter, zero out the clamp-on-amp probe to prevent a skewed readout, and proceed to make the necessary measurements. We can see here that in this triple discharge, the first pulse is nice and slanted as previously explained. The second pulse looks more like a defective coil unit. This is normal in Ford ignition systems, due to the fact that the magnetic field hasn't completely collapsed before the second and third ignition pulses kick in. Whenever current ramping a Ford ignition system, always use the first ignition pulse as a guide. Remember that this system is only employed by the Ford Motor Company family of vehicles, and in this regard, the second and third pulses are void of any current ramping information. In this particular case we don't have a problem, and we do have a smooth rising magnetic field buildup in the coil unit.